So for an update today, turn screen sharing on my second machine I've got going here. Bear with me. It's running Gazebo and Arviz, so it's a little bit slow. I still haven't fixed the speed issue, and before I tried to dig into that very much, I wanted to try to make sure I was working on the right YAML files and config files and whatnot. So I ended up consolidating a number of files into one workspace that's out here on GitHub. One of the things as well was the wheels were a little bit submerged in the ground. And so I worked through changing the origin statement in the base footprint to, I think they're basically on the ground at the moment. And I'll walk through a little bit of this workspace here in a second. Following that, I'm like, hey, I want to have a consistent path that I'm testing in the simulator while I'm trying to work through this speed thing. So I thought I would go relearn how we did this path generator thing a number of months ago. So at the moment, I've still got to get the TEB planner to run the vehicle at plus or minus 2 meters a second. Path follower also, I noticed, which would use the output of this generator, is based on move base flex. So we'll have to resolve what sort of path follower, whether to try to change the lawn tractor to move base flex in the simulator or try to get a different path follower. So for me, the next thing is maybe get the path follower worked out so that I can follow a consistent path over and over. Well, so it'll be a little bit maybe more consistent in resolving the speed, and then resolve the speed issue, and then work on the low level controller. Oops. This will be familiar to Jeff, but what this is, Terry, is this Python program, you give it this is, I gave it 4 waypoints or 4 points, and that are in this waypoint text file. And it generates 2 things. One, this image, but more importantly, it generates, about 5 or 6 waypoints for each point. And so that's what I want to run, consistently, just to work out the kinks in my steering and whatnot and speed control. And then on the working on the speed thing, Jeff, I've got half a dozen or so URLs to sort of investigate. A couple of them leaned into a little bit. One guy was saying, hey, you got to make sure your acceleration limits are high enough. Mine are sitting at that point, 3.2, 2.5, and 2.5, although I want to make those more consistent. I'm not sure that's going to do it for me, but it's just a little bit of where I'm at. If I go back to
what are those velocity units?
I'm not sure. I believe they're meters per second, but when it comes to these limits and theta and whatnot, I'm assuming they're meters per second. And I had just put some arbitrarily high numbers in there, hoping to get something close to that from a speed standpoint. But
what's your actual question, Terry?
I'm kind of jumping ahead to setting my PID, and I'm wondering what units to set for a PID. Is it revolutions per second? Is it distance traveled per second?
In ROS, as a standard, all velocities are represented in meters per second.
That's
All rotational velocities are radians per second. Angles are in radians and distances in meters. So it's, just combinations of those.
that's what I needed to know.
So when you're all done, ROS is going to say, I want you to drive forward at 0.5 meter per second. So you do whatever it takes to convert that 0.5 meter per second request into making your vehicle move at that speed, is what it comes down to.
And if you're making a curve, but you don't have a steering as your tractor does, but rather a differential, is that go this distance at this velocity at this turn radius?
They will give you the standard way to do it. They say, here's the forward speed and here's a rotational velocity. So
Okay.
again, it's up to you to convert rotational velocity into making a turn. And the simplest way on a differential drive, you just simply say left wheel is forward speed plus rotational velocity, and left one is forward speed minus rotational velocity. And that will convert it to the point where your two wheels will turn the speed to do what it wants you to do.
Got it.
Later, I said you might have to add those and then divide by 2, but it works. It works either way. Now, the other thing, what I thought you were asking was, it'll say max velocity X, max velocity Y. Well, in the ROS world, straight ahead is X and left and right is Y. So that, and Z then is up and down. And that's why you'll see these things listed with, velocities X, Y, and Z, or whatever X, Y, and Z. That's what they're talking about there.
Got it. Sorry to interrupt, Al.
Yeah, you're fine. The other thing I just wanted to touch on briefly is a little bit about how I moved the programs into one folder. So this is what's out there in the source is just this folder, Ackerman vehicle. It's got a URDF nodes, maps, launch config. As you can see, each of those has in it what you would likely expect. Here's a number of the Zacro files. I just carried over all of them that we had in the nodes at the moment are these Python programs. Obviously the path follower, path generator, that's specifically for doing something with this waypoint file, as well as this generated point. So as I was mentioning earlier, it's a little bit easier to see here, like the numbers on line 1, 11, 22. Thought I gave it 4. 1, 11, 22. Maybe, I know I gave it 4, but anyway, it generated these other, 2 through 10, and that's what's ideally going to be fed into some sort of program like path generator. But as I mentioned, this path generator that we had in our archives is pointing to move base flex. And so in this version, I'm not using move base flex, I'm just using move base. So I have to work through that. Other things maybe to note. And this, it just makes it easier for me if all of these YAML files are in one folder and I don't get, it's a little bit easier for me to not get confused. Anyway, that's like I said, where I'm at and where I'm going, work out come up with some sort of path follower routine to, do something with these waypoints, and then run that consistently and see how the speed might change as I muck around with the configuration files. That's where I'm at.
So last
Okay.
week I was saying that I was talking about wiring, and I had these things called ferrules, and I don't remember what else I talked about. I was just in general, I was talking about wiring, and I said I found these things called ferrules, and I don't know if you can see these or not. These are just little. This thing right here is a thing that crimps on. So it's actually kind of a round. In fact, it is a round pin on the thing. So you slide your wire inside. And this happens to be 18 gauge speaker wire that I found in my box. And since speaker wire isn't marked very well, although here you can see the white, here you can see the white stripes on it, but I can never find those white stripes that I'm looking. So what I did, I took pieces of heat shrink tubing. I found some red and some black and stuck on there. And they're not shrunk on right now, but if I were going to go ahead and use this, I'd shrink those down so I don't screw that up, and then I prep the other end of it. I'll put those on too so I can see what I'm doing. So the advantage of these ferrules is if you've just got stranded wire sticking out, once you put these on, you don't have random strands of wire shorting out on things. And if you put them into terminal strips, like say these terminal strips, it's got the little screw on the top, and you slide something into that, you can put wire in there and crank it down. But for some reason on mine, all the stranded wire always seems to work its way out. So by putting these things on, let's see if I can get this to fit here.
It sounds a lot easier than what I've done, which was put a drop of solder on it.
You can do that, but it turns out these worked fairly well. This is the first time I ever tried using these, and somebody else, I think it was Alan. Is either Alan or Ross, the guy from I think he's from Kansas, and I think he says he uses these a lot. And see, basically you slide it in like that, and if you can get it to fit, you crank down on that, and that'll give you a good solid connection, and hopefully they won't pop out. So then when you buy them, I just bought them on, I think, Amazon, and I got a package like this. So there's a whole bunch of them in there, and see there's some really big ones here, and then it works down to small. I think it says 22 gauge up to 10 gauge, and then it comes with when I bought it with this crimper. And if you look at it, you can see the hole. Yeah, see the hole looks like a round hole. So you put the thing in there, as you squeeze down, it's actually a hexagon, and it just makes it smaller and smaller until it smashes it against the wire. So it works just like the other crimp on terminals. It's just that they're round instead of the little spade connectors or whatever. And I was going to post my link to Amazon where I bought these, and of course I can't find this exact package. There's other ones that look like they're basically the same thing, from different brands and whatever. And if you look at it, see there's a whole bunch of them in there. I don't know how many, that's probably about a lifetime supply, unless you get really start liking these and then putting them on everything. But so that was the thing I was talking about last time. I said you could use crimp on ferrules, and that maybe will take care of some of the problems. The other thing was this doesn't really relate to much, except that this is a single channel Cytron driver board. So Terry got one that's dual channel, and then previously people be using the big 30 amp one to run their power steering motors, and that's what I drive my mini tractor motor on my little vehicle that I made. And Terry's having a problem. He couldn't get the thing to run. He set it up, and it's got push buttons. This one have push buttons on it.
Should have one. No, it should have two.
Yeah, it should have. Anyway, I can't see. Oh yeah, there they are. They're at the side here. So they give you these test push buttons. You can push these, and it makes the motor run one direction or the other. And he said, I should let him tell the story, but I'll tell it anyway. He set it up, and he got it to run. He could push the buttons, his motor would turn. He hooked up his microcontroller, and nothing. It wouldn't do anything. So I was out digging, and I found some tutorials where they're showing that the the wire, the ground wire between the logic and the battery, they had them hooked together. They specifically said hook those together. And my thought was it's probably connected on the board, so you shouldn't have to do that. But he hooked them together and it started working. And he disconnected it and it still worked. So we were baffled on that. So I just took an ohm meter here as the meeting started and checked. And sure enough, on one side, the ground pin here for the incoming power and the ground pin on the logic over here are connected together inside the board. So whatever Terry's problem was, it's still baffling. And so someday we should track that down and figure out why. But anyway,
I haven't had an issue with it, and I have not connected that ground back together. So
yeah, and you shouldn't have to connect those grounds together
Right.
because they're connected on the board, which brings up problems later when we talk about noise problems. So someday
I have a
we'll
feeling
have to
it
go
was
through all that.
probably a operator error.
It might have been, and I don't know. So anyway,
I'll take that one. It was an operator error. I'm still proven otherwise.
yeah, you do have to hook up the logic ground from the board to your logic just to make sure you have a ground connection between.
Right.
But then you shouldn't have to hook up the one between the battery and anything else. So, oh well, we'll keep that in mind, and then if that comes up again, we can dig into it and figure out why it was doing that. So. The only thing I did on my robot, I went out and bought some more screws. I got some that have like a bevel head. They're quarter 20 bolts, and I had big bolts sticking out of the top of the thing. And I simply went out and bought these other ones and took a countersink and did a countersink, so it's got a 45-degree hole inside the board that I was using. So that way those are flush with the surface now. So I put those on, and I was over at Menards. I got some other screws to replace some of them I have. So that's really all I've done with that. So I think that's all I got to report for this time. So I'll turn it over to, I guess, unless there's any questions on any of that stuff.
Nope.
Okay, so we'll turn it over to Terry then.
Okay. I found a Reddit on Milwaukee Tools. So I posted there to see anybody have the battery protocol. And one guy said he had the dump of the hex, but I don't think I'm going to try and debug or deassemble the hex code in the PIC processor. I found another guy who responded, quagmirerepair.com. He has taken apart the board inside the battery and is basically creating the schematic, reverse engineering the schematic, and found that it has a, let's see, what was it? A BQ battery control chip, and then a small PIC processor. And he identified that the PIC processor is connected to at least J1 through some other components. And so now he's doing the work of re-engineering the board. And eventually I plan on using my USB SX logic analyzer to kind of watch the flow of data between the battery and my drill when I run it, and also between the battery and the charger, just to kind of see what the communications is going over, what format it is, and see if I can debug it that way. But at least we're making some progress.
So a couple of points on that. I found somebody's website that says we're going to reverse engineer that. He created a GitHub, and about a year ago he just archived it and he was done with it. So, and that's one that was, yeah, as you say, somebody was showing hex dumps of something, which I assume it was a processor, and I didn't notice anybody saying, showing, actual protocol going back and forth. And back to your point about if you can just hook it up and get it running and just watch it with your analyzer, that might tell you something fairly quickly, because a lot of stuff on I2C, they'll use the concept where they'll say, go to register 3 and give me that value. So you should be able to watch, just little short, you should see little short messages, and it'll say number 3, and it'll give you a number which probably will represent voltage or current or something, and say, might say number 4 and give you something else. So just watching that might tell you enough, because I don't think they'd go to the trouble to try to encrypt that in any way. They could, and a real simple way to encrypt things is just flip some of the bits when before you transmit, you flip some of the bits in your word, and then send it. When you get it back, you flip them back, and that'll stump most people right there. So that's something you could watch, and get the drill running and run the thing, just run it slow, and then ramp the speed up and see if your numbers stay consistent. So there's various things you can try there.
That's one of those. It'd be nice to know. I think, yeah, I'd like to do that. I think I'm gonna, for the short term, just put voltage divider across both of the across the battery, and then use an A to D on my itsy bitsy to read what the voltage is, figure out how to calibrate it, and then have it generate a message when it gets to like the 30% down or 30% remaining, and then a shut off message at the 20%.
And I think there might even be some standardized messages in ROS that are for battery stuff. So it could be you can find a message and plug the values into that and publish that. And it might give you like, your instantaneous voltage. And then I don't know if their message was set up to do an alert saying it's down to 20% or whatever, but you can create your own messages to do that too. So if that's something you want to do, you say, okay, I read the voltage and it's down to 20%. You just publish off a message saying, my battery is low, and then you can do whatever you want with that. So
that's why I was wanting to have kind of go find the recharge station as one message it sends out, and the other one is, okay, you're going to stop now, and takes human intervention, because it sounds like there's some bad things can happen to the battery pack if you run it beyond a certain point, that it won't charge again.
And it could be the battery smart enough to shut itself down on that. I was reading when I was digging for your batteries, I found a lot of people saying, well, it's I've had it for 5 years, but I've only used it twice and now it won't charge. And then various people on YouTube said, oh, go out and buy this little battery. I can't think of it. Equalizer, I think it is. So you get this little board and you take the battery part and solder the wires on, and somehow it equalizes drains the high ones down and lets the other ones charge up. So that they had some way to fix them. It just looked like a real pain. Although if they're $100 a piece for the batteries, it'd be worth some trouble to buy a little $5 board to correct for it. So yeah. But one thing that bothered me, that people would pop these things open and they said it was fully charged. They started poking around in this thing. There's a lot of power there with just these big tabs sticking out there. So be careful as you do that, so you don't short anything out, because you might have a mess real quick by doing that.
Right.
And then he had these just flying leads coming off the little board, and he just grab one and solder down, grab another and solder down. And as he did, the little LEDs on his equalizer board would light up so he could see what he's doing. And but yeah, just in general, keep that in mind, that you're working on something that's live there, because you have no way to turn that battery off, because you're right on the battery terminals themselves.
Right. So that's kind of where I'm at with the battery. I want to get my PID at the motor level, and then do PID based on the robot itself. But I need to calibrate what the wheel size is, so I can determine meters per second based on a rotation.
And you intend to have the quadrature encoders on your wheels, don't you?
I do.
Because that way I go.
Well, no, they're actually on the motor, but I'm on my prototype. It's a direct drive. So in essence, it is directly to the
The only difference there is with if it's on the motor as opposed to the wheel, that you've got some ratio, some gear ratio in between there. So yeah, but my point was, what I find it convenient to convert the meters per second into counts per second on your encoders. And then you do have to at least once calculate how many counts the entire diameter of your wheel is, on what your encoder is going to tell you. But once you get it down to the point where it's encoder counts per second for speed, and then distance is encoder counts over time, that works out well. But yes, yeah, you're right. At least once you have to take the diameter wheel and figure out what I do is I like to ideally, if you have code that's set up to do position, you can say, okay, this is position 0, and then run the thing around to where you think it's gone exactly one full turn, and then look at the thing and say, how many counts was that? And then punch that back in and say, drive one full turn, and see if it stops where it's supposed to. And you get at that point, they say drive 10 turns, and then you can see it, does it come out exactly where you want, where it stops? So that's just another handy thing to do, but that's not really, to start with, that's not really all that important. Just get as close as you think is right, and then go with that. Then some other day, if you want to get it down, if you're off by a couple of counts, then you can fix that some other day.
It looks like I've got a very, if I remember right, each turn of the motor shaft, if I remember right, gives me 188 pulses. And if I remember right, the motor has 100-to-1 gearbox. So I'm getting like 90 to 100,000 on one turn of the wheel.
That all sounds yeah. Sounds like you know exactly what you're doing there. So that's
I'm remembering back 10 years ago when I was working on the PID at Alan's place. I know it was really fun to watch. We had put the PID signal on the scope, and you were able to watch as you put some resistance on the wheel. You can see the PWM wavelength increase, and it was fun to watch it change based on how much tension you put on the wheel. It's just neat seeing that visual feedback on the O-scope. And then
another handy thing on that, if you start using the Arduino IDE, you can pull up that what they call the serial plotter. So you can take all your different values and plot them out like an oscilloscope, so you can watch it. So you can see the same thing as you put your hand on. It'll say, here's my current speed going along like this, and then down here's the motor power. And you put your hand on, you'll see the speed start to come down. You see the power come back up to compensate. So that's another handy thing if that's how you're programming your board. You just fire that thing up. Well, whether you're programming it that way or not, that's just a general program. It'll say, take these incoming values and plot them on the screen. So you could program your board in something else and then plug it into an Arduino IDE and still get that to work. So that's just a quick way to see what's going on there to debug stuff.
Does ROS do anything about I used to call it the trapezoid acceleration curves, so that
I think it will generate that. The thing that Al was just showing, he said something about acceleration limits. I think that's what that's doing. So you can change those numbers. That'll when it puts out commands, I think it'll actually ramp those up for you somewhat. But my thought is you might want to keep in mind, you want to do that. You might want to do that yourself. And if you don't end up needing it, just set those to say, make it a step function and just ignore it. Let ROS tell you how to do it. But while you're working on it right now, keep that in mind that you might want to set it up. So if you type in a step function, say go from 0 speed to whatever 100% speed is, maybe a meter per second, that you might want to put a ramp function in there yourself to control that. But
I remember that I had done that when I was using the 68332.
Yeah.
So I'll have to see if I can dig back and find that where I documented that. I remember I did like 9 scenarios, so that if you were going from dead stop to dead stop versus going dead stop to a slower speed, same speed, increased speed at the end of that position change. I had, I think, 9 different trapezoid configurations that it would do.
I saw a video a few days ago where a guy was looking for the right microcontroller to measure the ticks on his CNC machine, and he was worried about losing ticks if his microcontroller was too slow. So he discounted most of the Arduino boards and went for a TI board that was running at, I think, 90 megahertz. I don't know with that many ticks, whether you would ever have to worry about losing ticks and the speed of your
This itsy bitsy is running at 120 and can be overclocked to, I believe, 180 megahertz.
But
and
I
it was the
think
same video that I didn't, well, I was wondering, well, what's the Teensy 4 running at? Do you know what it's running at?
600 megahertz.
600.
But,
I'm
but
like,
keep
holy
in mind,
cow.
we're talking about 2 different things here. You know, when he says the Arduino is too slow to do it, that's because it does not have a built-in quadrature decode peripheral. So you're relying on the processor to do it. So you go out and you get the ARM chips that have the peripheral built in. They'll take something like a 2 megahertz input. The counts from your encoder can be up like 2 megahertz or something, and you're totally avoiding all this nonsense they do on the Arduinos, where they create their own quadrature decode functions to do that. So you really got 2 different things there that you're talking about. But yes, to start with, if he just takes his board is faster than a regular Arduino, so he's got a much better chance of that being able to keep up if you have to do that. Now, as I said all along, I prefer to just buy a processor chip that's got that built in. And I had the TI, this one's got a little TI eval board in here, and it's got like an ARM Cortex 4. It'll do 2 channels of quadrature decode. So you just hook it up and those just work. And then all the ST micro parts seem to be able to do, I'm going to say all of them, and that might come back to bite me if I say all of them, but even that little blue pill, which is like the older, I think it's like a Cortex M1 or something, that one will do it too. So the quickest thing is hook it up to what you got, drop in the Arduino quadrature decode and see if it works. And if it works, go ahead and use it until you decide to do something different. If it doesn't work, then you can look at something, you know, taking a different approach to that.
Sounds good.
And then
Let's see.
the other thing I keep thinking about is those little blue pill boards. You can get them for like $2 to $5 a piece, and it's like a 45 to 90 megahertz ARM processor, and it's got the extra peripherals built into it. Because you can always use one of those as a peripheral processor, and then talk to whatever processor you got on the board. So hooking them together with I2C or UARTs or whatever, and just program the little board to do just the stuff. Like in that case, you get the quadrature decode for free if you drop that board on there. So, more things like that you can think about. Try it on your itsy bitsy board first, using the Arduino libraries. If that doesn't work, then we can come up with some other way to get around that.
I'm using a encoder library that's specific for that chip. It's not specific for the board, but for the SAMD 51.
Well, be careful, because the 51 and the 21 may be different. It could be it has the peripheral in the 51 and not in the 21.
Right, but it's built specifically for the 51.
Okay, but you don't have a 51. Right?
No, the ITSY has the 51.
Oh, I thought that had the 21 on it. Anyway, that's things to think about. Just keep that in mind.
Okay. My plans are to complete the PID on the rounds per minute, which will then be, I'll be able to calibrate to meters per second for the PID on an individual motor, and then work on getting it for going straight with the robot at a PID, and then figure out how to work in the turns.
Sounds like
Okay.
fun hardware work.
And hopefully along the way, wire up my batteries actually onto the robot. So they're fused and switched and so forth, instead of having to unplug the battery when I want to stop playing with it.
So how many cells are in that battery?
I believe 5 to give 18 volts. Maybe it's 6. No, I think it's 5 for this one.
The reason I ask is because after the last call, I looked at some of that Milwaukee stuff, and I don't know exactly what you were trying to reverse engineer, but I assumed those middle wires were not digital signal wires, they're voltage wires for the battery management system.
The battery management, I believe, is actually in the battery itself. And the 5, the outer 2 are the battery output plus and ground. The middle one is battery voltage input. And then I'm going to call it 2 and 4 are the communication lines.
So, I mean, you're like a digital signal, not. So if the okay, I mean, that would be fascinating that they put the BMS inside of what you just held up.
Well, that's where they're using that. Let's see if I've got it over. The BQ chip and the PIC processor.
And that's in
that's actually in
what you held up.
It's in this M18.
Interesting.
This the Quagmire Repair, he sent me an email back showing the boards that he took off of when he took the pack apart, and he's documenting, I guess, all of the connections that he's finding and all of the parts that he's found in there.
Interesting.
But he started it January 1st, so he's still very new into it. I mean, he's done a lot of back engineering, but
just as a I mean, an interesting point, that the battery that I have on my tractor has its own, well, I mean, it's a DIY job, like a Frankenstein thing, but the BMS has a Bluetooth connection, and I'm able to get it here because this room happens to be over the garage, and the battery has gone from like 14.3 volts to 14.2 volts in like 3 weeks without being used or charged. So I thought that was pretty interesting. But it has 4, I don't know if you can see, there's 4 cells there, and each one of them have separate voltage.
So, yeah, I don't know how much information is available, and that's why it would be great to get the protocol from Milwaukee, but I don't think they're going to give that out.
Yeah, I mean, if that's a digital signal, then you could write your own code to sit there with your own
Exactly.
Bluetooth thing with your phone and see what's going on with your little battery. That'd be sweet.
And if I can figure out how to do the reads, then just kind of sequence through till I get nothing back. If they're register locations, memory locations.
Cool.
Do you have that plastic adapter handy right there that goes on your battery? Is it going to be convenient? Could you put a couple extra tabs in there and hook your wires onto for your signal?
It would not be convenient. You'd have to pretty much take it apart. What I would probably do then is got a friend that has a 3D printer and see if he could 3D print it for me with the extra tabs.
Because that's just something you'd have to think about as you go along here to figure that out. But or you might be able to just solder some wires on some tabs and shove them in your battery and they just hot glue them or something. And so the wires go with your battery as you're moving on and off, as long as you're not going to try to put it back on your drill. That would be a way to do it.
Right. But no, my expectation would be that once if I get the protocol figured out, at least to get the battery capacity and voltage levels from the battery pack itself, that I would have to get or make a new jack, I guess would be the best term for it, that has all 5 in place.
On that adapter, is there any kind of a latch on that, or you just simply put the battery in, your gravity's going to hold it down to keep it in?
Well, the battery itself, see if I can, has this squeeze and it connects. It's a hard connection into, it's a latch into that adapter.
Okay.
So that when I do this, there's a hard snap and it won't come out until I do this.
Okay. And the other thing, keep in mind, you can use that as your switch too. So when you're all done, just pop the battery off and lay it on the table, and then you don't have to have, you know, a big power switch in the way. That's just one more thing to screw around with. So that would be handy too, if it's convenient to get the battery on and off.
Well, I already have that switch wired up from my old system when I was using the RC batteries, where I had one set of batteries giving me 21.6 volts and the other one giving me the 7.2. I did, oh, that's another thing I did get. I got this switching power converter that takes between 7 and 36 volts down to 5 volts, 3 amps. So that, and that particular form factor, they've got it up to, I think, 20 amps. But I only got the, I've got a pair of the 3 amps.
Tons of rabbit holes to go down.
Yep. Which is why I think the just doing the voltage divider and monitoring the voltage is probably what I'm going to end up doing for the short term, unless I find someone who's been real ambitious with this and decoded the protocol.
Fancy term is minimal viable product.
If you can figure out a way to connect your your logic analyzer to your battery while it's on the drill. You could go ahead and take some dumps at it and just see what it looks like. And if it's real I²C, I think the USB analyzer says apply this decoder to it. You can say it's I²C stuff, and it'll show you. It'll help you out somewhat there, so you're not just looking at lines wiggling at that point.
Right.
And more than likely, especially if they got it connected to a PIC processor, they probably just use the I²C peripheral in that. So I'm guessing it's gonna be real I²C. So then it's just a matter of, say, oh, I found a start bit, or what do they call it, an I²C, and then the standard protocol is something like, give it a number that's usually, you can either think of a register number or a command number, and then there will be one to several bytes of data. Depending on what they're trying to send you. If it's a voltage, it might send you a 16-bit number or a 32-bit number or whatever. But if you can see those, and then while the thing just runs, just check those numbers over time to see if they're changing. Especially if you have two different batteries laying there, one that's charged and one that's not, go back and forth between those and see what the numbers look like between those. So that might give you, if nothing else, you could probably get the battery voltage out immediately by doing that. And then if it's capacity left, again, swapping batteries, you might just be able to see that change between the two. So that might be, a fairly simple thing to do. And I'm guessing those are going to be 5-volt signals on that I²C. So you might want to check that first. We just put a meter on and see, do those pins say 5 volts or do they say something other than that? And that,
Right.
I think a USB probably works on either 3.3 or 5. Is my guess. I don't remember. It's been so long since I've used one of those.
Well, the USB is that's very forgiving.
Well, forgive 18 volts. Since your battery's 18 volts, they might.
I would be very surprised if it's doing its communications given that it's with the PIC processor, that it would be above the 5 volts.
They
I
may
just
have
don't know.
something in between there. Yeah, I think it'd be foolish for them to put 18 volts on that signal. But again, if you just measure, take a meter and measure it and see what's on there before you start hooking stuff up to it.
Yep.
And in fact, it could be if you just, with the battery layering there on the table, because the thing is powered up right now. It's all the electronics are running right now on that battery. So just, look at it with your thing, and it could be that it's just randomly talking out there saying, oh, hey, here's my voltage. Oh, here's my voltage. But it could be, you have to prompt it. You have to go out from the outside world and say, tell me what this value is. So
That's my guess, is that it's the non-battery end is going to be is considered the master, whether it's the drill or the charger, and that's going to request the information from the battery.
that probably makes sense. Yes.
I guess the other thing I've done is I have gotten, I still have Ubuntu 20 loaded onto an old laptop. I have not done any more with loading ROS on there. Don't want to split my focus too much. I have ordered some 3.3 volt Zener diodes so that when I do my voltage divider, I can make sure that I'm not putting anything over the 3.3 volts into the ADC. Those aren't scheduled to get here till somewhere between the 19th and the 26th.
Yeah, hardware, software, configuring PIDs. There's only 2 or 3 more things you got to do, Terry, and then you'll be set.
Okay, I've got a phone call coming in that I need to answer, so I'm gonna go silent for a moment.
Okay.
Anything else, Jeff?
Well, when we're all done, I was going to ask Terry when he started the Twin City Robotics meetings, but we'll wait and see if he comes back on that, or if we run out of things to do, I guess we can just move on. I was thinking, last time I was saying I should check out my giant RC servos to see how well they're tracking. And you said, hey, you should make up a video on that. Well, I haven't made up a video yet, but I think if I just say, here's one of my RC servos. And if this one doesn't have the wire soldered on the pot yet, but if I'd go ahead and solder that wire on, if I just connect this to say an Arduino Nano, so the Arduino Nano can generate the PWM to tell it to move and then measure the analog coming back, I should be able to do something that says I can plug in a servo and then write some kind of software that says, go through some pattern and track it to see, is it following like it's supposed to? And then I could try it on this one. This is just the Chinese one, random Chinese one. I think I bought on Amazon or eBay. And the one that's on my mini tractor I thought was working well is the one from MPJA. And I noticed those are all out of stock. So I don't know if they're not going to sell them anymore. I don't know if they can't get them or whatever the deal is on that. And then I can plug in my here's the Super Servo 200, and this blue wire is the feedback wire that I put on the thing. So, technically I can try any of those. And I assume if I go into just a standard servo like this, that's what, like quarter scale, I'll probably, if I go to the pot inside that solder wire, I can do exactly the same thing on this. So I could check it against, real servos as opposed to, as opposed to this one that somebody's hacked up. So that would be an interesting thing to do. And I think it would be relatively universal. Then I could try it on, a micro servo and a standard servo and a quarter scale and so forth, just to see how well those things track. So that would be a worthwhile thing to do if I get bored. And the only difference is the big servos put 5 volts out. You put them on 12 or 24 volts into them and they put 5 volts out, and the other ones like a standard servo like this, you have to actually supply power like 4.8 to 6 volts power into the connector. So that's the difference between those two. I thought I could see through the servo when I was doing this, but I must have just been reflecting blue light from somewhere. So I guess I was confused there for a second. Well, that'd be handy to go through, whatever I can find laying around, try various ones and run them through the same program and plot out the response on them just to see what they do. So that you're right, it would be good to make a video on that and put it up so other people can look at that and see it. That's all I got to say about that at the moment, I guess. If I get back to that, I'll have more to say on it, but
Good deal. I think I'm all set, gents.
you know,
I'm all set.
okay, well, I'll stop it then.